So let's continue the previous conversations and look at the header files. I don't know much about these header files. I'll be searching all of that on Google itself and trying to understand these macros that are defined here. And there are actually, let's just see the macros for now. How many macros are there? So config id of target is one macro. How do you uh, find this macro is, I think, very easy, and it's in the convention of C language that all macros should be uh, capital letters. So basically, a variable that uh, is used for macro should be all caps. So this is a macro, this is a macro, and there are no macros here. The ESP is a macro. Chip feature EMB flash is also a macro. I think this is also a macro. I'll just have to see whether this is a macro or not. Most likely this is some type of output. PRIU32 says unsigned. I think it says unsigned 32. I don't know, primary maybe. I don't know. Then there is one more macro called port tick period ms. I don't know why this port tick period ms port is in like small letters. I'm not sure. So let's just continue with the header information. Um, so the first one is stdio.h. I think if you know a little bit of C, then you know that this is a inbuilt header that is defined inside standard library itself, and this is a standard header called stdio.h used for input outputs. Like for example, this printf is defined under this stdio.h. Then there is int types. I don't know much about that, but since it's under triangular brackets, so it's defined, and it comes with C itself. So int types dot h is also inbuilt library. Let's just look at what is this header. So int types header provides fixed with integer types. Basically, if you want to define a 32-bit specific integer, then you can use this predefined header. Like for example, there's int nt. That's a common uh, defining type. N is can be any number of bytes. Is what I think. That's macro, right? Okay. So int types itself has this pru max, sen max. That are the macros. So here there is one macro, pru32. Let's see pru32. What is it? Let's go into AI mode and tell that I have this Pry U32. What does it mean? Pry U32 printf ensures that variable unsigned integer 32 is printed correctly on any system. It is defined in types.h. Okay. Pry is for print, which is used for printf. U is unsigned, 32 is a 32-bit integer. Okay. So pru32 is defined is a macro defined under int types, and it says that print, like it is basically used to print any type of 32-bit unsigned integer. Cool. So this means that ESP get minimum free heap size gives us a unsigned 32-bit integer, which is used here in print. I think this macro converts the 32-bit int to string, and these three strings are concatenated uh, to print a final line, which is shown here. It's basically minimum free heap size, which is here, percentage something some value, which is this 479400, and bytes. It's cool. Okay, there is one more pry32, which is okay. You can see here that there is unsigned bit 32. Uh, this value is being converted to unsigned bit, unsigned int 32 bit, and there is flash size. Flash size is uh, where does the value of flash size come from? Hmm, okay, okay. I think so. It gets the flash value from here. Basically, flash size is defined as unsigned integer 2, and it's given to this function, which gives us back the flash size of ESP32. Cool. Okay. So this is done. So basically, in types is basically a type definitions, integer type definitions with constrained bits or specified bits. Then there is free artos. I am supposing or I am assuming that this is a free artos definition. Everything, every functions that are being used, uh, every task that are defined here. Free artos. Then there is task.h, which is again under free artos. Then there are three more, and there is sdkconfig.h. Let's see what is this. Okay, include sdkonfig is a C++ preprocessor directive used in ESP32 to include project's config files, which is automatically generated from the settings in the ESP. Okay. Okay, so basically, uh, IDF defines some configurations. Like for example, one configuration was setup config, sorry, set target, not setup config, set target for ESP32C6. So I think it defines some basically directives which are being used specifically for say 32C6 controller, which I'm using. Okay. If you get find found error, ensure projects built in a separate using generated. You can use idf.py to edit SDK file, which will generate the SDK config header file. Okay, let's see if we can find SDK config file. Can just use this one. idf.py menu config. Okay, deploy config serial flash. Okay, and then it's for save. This actually saves to SDK config. Okay, okay. So SDK config is under hello world. Let me see. Let's quit. Let's quit here. Clear out terminal and see. Okay, there are three files: sdconfig, sdconfig ca, sdconfig alt. Okay, might this config file might be used to store older values. This config and this config, I'm not sure what are this. H is a file generated by the build system. Okay, let's go under sdconfig. Okay, I think sdconfig is a file and not a folder. Okay. Build system uses the sdconfig file to generate sdconfig build directory. Okay, so this file is being used to create sdconfig header file. Okay, under build. Let's go under build and there is no sdconfig file. Okay, making configuration available for the config for time. This is generated sdconfig file. If you're using different environment, ensure do not manually copy sdconfig file. Okay, let me know if you find sdconfig.h file anywhere in the comment section. I will for now skip this, assume that there is sdconfig.h file present which is being used here. Cool. Then okay, ESP chip info.h. I think we can actually see this header file somewhere. Let me see if I can find that file. Okay, it's not here. Hello world.bin map, cool, partition table log. Okay, it's not here. Let me go here. There is no header file. Let me go one more. Let me go here. Hmm, see configure name. Okay, where does it file get stored? It's a C++ directory that includes chipinfo header file, which contains definition for functions like chipinfo. Okay, where is this file stored? Hmm, let's ask to AI mode. Where is this file stored? So file part of okay ESP32 components hardware support include. Okay, let's go back, clear out. Then it was under components hardware support. There is a component folder. Let's go inside that. Oh, wow, okay. There is DEF hardware support. Okay, found it. Hardware support. And then if I go under include, and there is ESP chip info.h. Wow, okay, found it. Let me just open ESP chip info. Okay, chip ESP32. Okay, there is enumeration type. C6 is 13. Cool. Then, okay, so we had this. Let me just open that macros chip feature Wi-Fi BGN BT BLE 802. All of them are defined as macros. Here you can see it. It's a bit 6, 5, 4, etc. Cool, nice. And it also is pragma once, which is basically telling that only define this all thing once. Then there is okay struct, which we are using here, chip info, ESP chip info outputs, or ESP chip info stores something in chip info, and ESP chip info is a struct. You can see it here. Where is that defined? Okay, it's a for GS, it's a enumeration with model, and model is okay for now. The struct GSP info T is a struct, and it defines this chip info variable. Then chip info variable is given to chip info dot h, which is not defined here because it should be a it should be it's like the declaration is done here, but definition is somewhere inside the C file. We'll see it later how it is different. But anyways, uh, takes a pointer as an input and outputs nothing, which is what is done here. Takes a pointer to a structure and outputs nothing. Then that pointer can be used, or that structure can be used to deal with things, which is here features revision course. And chip feature X has bit mask. Chip feature, where is chip feature? Okay, these are the chip feature defined. This, if you mask this, which is basically and this, and it should give you the information. Cache lock fix, then we'll run this. For now, we'll just skip that. Major revision. Okay, then there is major revision, minor revision, which is again taken from revision, chip input dot revision, which is you can see defined here. Chip revision number, where m equal to major version, xx minor version, which is dividing by 100 taken a reminder. Then there is ESP flash get size. I think it is defined in ESP flash. So let's look at ESP flash now in ESP system. Okay, so there a ESP flash? Okay, there is no ESP flash here. Is there a ESP system? Okay, there is no ESP system. Clear. ls. Let's go back to parent directory ls, and okay, this power supply folder SDK info. Okay, this MAC address port and memory details GPIO DMA. Okay, so let's see where this flash is defined, where this header file is present. Flash is located in SPA flash. Components SPA flash include. Okay, let's go back. Components. There should be SPA flash. PQRS SPA flash. Okay. CD SPA flash, and there should be. Okay, I have to go inside include, right? There should be include. Yeah, there is include, and there is ESP flash. Open ESP flash.h. Okay, there is structure, this function ESP flash t defined. What is it that it uses? Flash size unsigned integer 32 and ESP flash get size. ESP flash get size. Okay, there is a definition. You can see it here, and returns ESP error type variable. ESP error type variable is defined. ESP error type variable. I think the definition is not here. I think it's inside this ESP error, that definition of ESP error type. For now, let's not go too much deep into the files. Where is my get info? Get size, sorry. Yeah. So it takes ESP flash type and unsigned integer. None of them is necessary, I think. ESP flash as a pointer, chip, and unsigned integer 32. And you can see there is a null pointer given for this chip and output size 32-bit. There is a address of flash size given, which I think is the value stored inside this. And then ESP error macro, ESP OK. Think it flash takes this ESP error, so the macro should be defined under ESP error, and ESP OK is just the value. Cool. Then we saw print unsigned integer 30 flash, and we actually haven't seen this macro portrait period ms. I think it's under ESP32 system. Let's see this. Where is this file? Components ESP system include ESP system. Okay, let's go under components again, and there should be ESP system. ESP system. Okay, let's go under that. Wow. Okay, system, and there should be include. Yeah, let's open this ESP system.h. Okay, I have ESP system now, and let's see this. Just find. Okay, there is no period ms. Where does it get defined? Let me see that. Where is this defined in ESP32? What it is a free RTROS macro. Okay, which is configured in sdkconfig.h. Okay, wow. Okay, so basically we have to look at sdkconfig.h. Where do I find sdkconfig.h? sdkconfig automatically is located in project build directory. You don't find this file in ESP32. Okay. Let's go to our project. Okay, there is SDK config. SDK config. Let's see. So it's not a directory. It should be ideally under build, and I should be able to find. There is no SDK config. Source of configuration project folder. You will find a file name SDK config. This file contains a configuration by running ID from config. Okay. During the build, use the setting from your config file along with default to generate generic location address page within the build directory, specifically under config. Okay. There is a folder config. Let's go under config. Yay, there is SDK config. Okay, let's open SDK config. Let's go and period MS is still not. But yeah, there are too many macros defined. Too many. Wow, okay. Too many macros. Let's see if I am using any of that macro in Macy. Chip feature, EMP flash. I think this was into ESP flash. This was in ESP flash. Sorry, my bad. Not here. Chip feature EMP flash is this bit 0. Okay. So everything is defined outside of its SDA config. I don't know what is this used for. For sure, this is used for defining the C6, which is 13 here. Where did it go? Yeah, oh, sorry. This cool. So I think we know what things are being done here. Basically, it prints hello world and then it prints chip information. For to get chip information, you have to define the chip info struct, then pass it into chip info function, which is defined under chip info.h. If you want to see the full C definition of the function definition of this chip info, we have to go to chip info.c file, which I should be able to find. ESP chip info.c located. Components, hardware support, port, chip info.c. Let's see if I can find components clear. Let's go under what was it? Hardware support. ESP hardware support should be under port. It should be under port, and mine is ESP32C6, so I'll just go under ESP32C6, and there should be port info. Port info. There is no port info. Chip info. Sorry, chip info. Open chip info. Yeah, let's go. Let's go. Let's go. There is memory set, which takes output info, and its chip info takes this out info. Okay, so basically this chip info variable is passed as a pointer, and first it sets the size of out info, and then out info's model value should be chip ESP32C6, which is a macro again, which is taken from I think here. I'll have to go into one more header. Fuck, bro. Revision is this. So I think it again goes from here. Course is one. Features is chip feature BLE, Wi-Fi BGN, and it's just a combination of this which it defines. So great. Bit 0, bit 1, and something. Sorry. Alright. I don't know the bit values of this. It should be inside this, right? Okay. So C6 has values. Basically, chip has 2.43 chip. Like here, you can see, right? Chip info.c has or three values. So basically, it has Wi-Fi, BGN, BLE, and IEEE 802.154 Wi-Fi. Cool. That is great. Now, actually, I understand few things. What it is doing. Nice, nice. Okay, that's it for this video.